Let's talk about the traveling salesman problem. The traveling salesman problem is a problem which is not typically numerical, but it's a problem where we can learn a lot. We can learn that there are still unsolved problems. Maybe you think every problems are solved. The traveling salesman problem is a still unsolved problem, and you and me, we can become famous if we invent something really new, and best if we find an algorithm which minimizes the total length of a tour. What is possible only is to find a tour which is close to the minimal, and sometimes for some specific configuration it was shown with an enormous effort to find in this configuration the optimal tour. But still there's no algorithm which finds always the best tour. This is Traveling Salesman. It's very easy to understand. The best is I show you some pictures, and here we are. I want to show you the idea of the traveling salesman. There is a starting point, which is here, and then you have to visit some cities. Here is one city, here is another one, and another one, and another one. And it's up to you to choose the order in which you want to visit the city. And it would make sense to choose the order such that the total distance traveled is minimized. One strategy is, let's find the city closest to your starting point. Then you will find that city here. And being there again, you can watch out for the city now closest, and it would be this city, and so on. And following that principle, you will get this tour you see here. But this tour is obviously not an optimal tour because of that crossing. And if you find that crossing, then you can improve that. This is the city with the starting point of the first edge being involved in that crossing. And here is the city where the second edge is being involved in that crossing. And now you can do the following. Let's remove the two lines being involved in that crossing and instead travel from that starting point to that starting point, and then do this part in the reverse order, and then being here, then do it in that way. And here you see that tour. Here the first city, go to the starting point of the second line, then go in reverse order here, and then there's no crossing. In this tour the total distance is less than it was before. Why? We can easily understand that. Compare this distance to that distance, and in a triangle this line is always less than the sum of these two lines. And then let's examine that triangle, and here we have the same. So this distance plus that distance must be more than this distance plus that distance, and so removing intersections will always reduce the total length of the tour. But is that tour the optimal one we have now? No, it's not. We see that here. This is our tour. The greedy strategy, always choose the city closest, and then after that remove the crossings. This is that tour, and here we see a tour which is slightly different in that area and also in that area, and also here we have slight differences. And the tour we see here, I think it's the best tour and it can't be improved, but I'm not sure about that. Our problem can be solved very easily, in theory very easily. We can try one by one every possible tour, and then we remember which was the best so far. And we can do that like we did applying selection sort. So it's very easy and we can find the shortest one. But how many possible tours are there? It's a very large number. It's faculty of 30, and this is very, very large number. And estimate the time we need doing that, then we find it's 100,000, more than 100,000 times 1 billion years. So the world is approximately, some scientists say, 4 billion years old, and now we need 100,000 billions span of time to find the minimal one if we do it like I explained here. So it's completely impossible. And there is no algorithm which can find the best tour in a helpful span of time, which means everything below 1 hour. And you can find an algorithm which solves that problem, and if you do so, you will get famous. And there are very large configurations where smart scientists are sure that they found the shortest one. That's not easy. It's easy in that if these are the cities, then it's very easy to know that this is the minimal one. But if we have some configuration like that, then it's not easy to find the shortest one and to be sure that it is the shortest one. Okay, which idea do you have solving the TSP? We can use the TSP problem to do some programming, basic programming. We can program the greedy strategy. The greedy strategy always choose the city closest to the one we are, and then iterating that process. And if you programmed that, then maybe you can also program the remove the intersections, and this is a lot of fun. I want to show you a little bit that fun. Very fascinating is if you programmed it, then you can run your code even for very large configurations. Here we have 150 cities, and this is the starting city here. And then applying the greedy strategy, you will travel to that city, then to that city, then to that city, and so on. This is the tour found by applying the greedy strategy. But there are some intersections here and here and here and here and here and so on. And then you can remove these intersections, and then you will get that result. But applying more logic, applying some different approaches, maybe you can even improve that tour. And I had some ideas and I programmed these ideas, and then improving that tour, my algorithm found that tour, and this looks quite good. And for example, here maybe it's better to go to that city, and this city you visit coming from here and then to here. I think that it would be an improvement, but my algorithm was not able to find that improvement. And maybe you find some more places where you think maybe this is a better idea. Also here, this is very obvious, going from here to here to here, and then you are able to go from here to here. This saves a lot of distance, so this tour is not optimal. And it's not easy to program to find a logic how to identify that. What your eyes can easily see, the algorithm is not able to see so easily, but feel free to spend a little time and program that also. But a warning, don't spend too much time. Maybe you will spend a whole week and it's not really numerics and it's not that important for your further study to spend 1 week, but it's a lot of fun, I think. Okay, that was the traveling salesman problem.